Richard Feynman. You've probably heard of him, Nobel Prize-winning physicist, right? But he was also, and this is the really cool part, one of the greatest explainers of all time. He had this incredible way of looking at the world, at something as simple as a flower or a glass of wine, and seeing, well, pretty much everything. So today, we're going to dive into his unique way of thinking.
You know, Feynman asked this question because an artist friend of his once said that science kind of strips the beauty away from things. But for Feynman, it was the exact opposite. All that scientific knowledge, it didn't take away the wonder. No way. It was the key to a much deeper, more incredible sense of awe. And that's really the big idea we're going to unpack here.
So, how did he get to this way of seeing the world? Well, it all goes back to his philosophy of teaching. For him, learning wasn't about cramming your head full of facts. It was about building a mental framework for thinking with just absolute total clarity. This quote right here, this is everything. For Feynman, intellectual honesty was the name of the game. You had to know, really know, the difference between something you could prove with what you already understood and what was a totally new, unproven idea. No fuzzy logic, no shortcuts. So this was his whole approach. He'd have this core idea, right? A central thread that absolutely everyone in the room could follow. But along that main path, he'd throw in these really deep, complex ideas for the students who were really leaning in, the ones who wanted more. He wanted to stretch them, but without leaving everyone else behind. And the most important part? The whole thing had to be a joyful discovery. It had to be fun. Okay, so how did he actually pull this off? How did he make these ridiculously abstract ideas feel so real and intuitive? Well, one of his secret weapons was the analogy. Let's take a look at how he used a super simple story to explain one of the most fundamental laws in all of physics.
Seriously, think about it for a second. The law of conservation of energy. It says energy can't be created or destroyed, it just changes form. But you can't see energy, you can't pick it up and hold it, so what did Feynman do? He told a story.
So it starts with this kid, Dennis the Menace, who has 28 toy blocks, and these blocks are indestructible. Every single day his mom counts them, and every single day she finds 28. Simple enough, right? This is our first observation. We've discovered a constant, a number that doesn't change. But then, of course, there's a complication. One day, his mom only counts 27 blocks. Is the law broken? Nope. After a quick look around, she finds the 28th block hiding under the rug. See? The law still holds. It's just like energy. Sometimes you have to look in unexpected places to account for all of it. And the story keeps building. Another day, she only finds 26 blocks. What now? Well, she notices the window is open, and sure enough, there are the 2 missing blocks out in the yard. This is just a brilliant way to show that a system isn't always closed. Energy can leave, but it's not gone. It hasn't been destroyed. And get this. Here comes the masterstroke. One day she only finds 25. Dennis is sitting there, guarding a toy box, and he will not let her look inside. But his mom is smart. She knows each block weighs, say, 3 ounces. So she weighs the box, subtracts the weight of the empty box, and the math tells her the 3 missing blocks have to be inside. She just confirmed their existence by measuring a totally different property, their weight. It's a perfect analogy for how energy changes form. And just like that, with a simple story about a kid and his toys, Feynman explained one of the deepest, most important laws in the universe. See, it's not just a fact to memorize. It's a whole new way of thinking about the world. This skill, this way of seeing connections everywhere, led Feynman to one of his most beautiful and profound ideas. That if you really, truly look at any one thing closely enough, you can start to see the entire universe.
Now look, this wasn't just him being poetic. For Feynman, this was literally true. He argued that every single field of science, all of it, could be found right there in that one glass.
So, first up, you've got biology and chemistry. The wine itself is the product of fermentation, which is a living process. And inside that process, you have this staggering complexity. This thing you're looking at? It's called the Krebs cycle. It's just one tiny part of the crazy chemical dance that turns sugar into alcohol. And it's basically the same fundamental process that powers almost all life on Earth. All of that is going on in the wine.
But what about the glass holding the wine? Well, that's not just glass. That's geology. It's made from silica, which is purified from the rocks of the Earth. And hidden in its composition are clues about our planet's history, clues that let us date those rocks using the decay of radioactive elements found inside them.
But then he takes it even further. He zooms out, way out, from the geological to the astronomical. Because you have to ask, where did all of this stuff come from in the first place? The silicon in the glass, the carbon in the wine, the iron that's literally in our blood. Where was it made?
That's right. They were cooked up in the nuclear furnaces of stars that lived and died billions of years ago, long before our sun was even born. So in that one glass, you have it all: biology, chemistry, geology, and the entire history of the cosmos.
But here's the thing. Feynman's genius wasn't just in connecting all the things we do know. It was in his deep, honest appreciation for all the things we don't. He truly believed that admitting your ignorance is the first, most important step toward actually gaining wisdom.
Take a question like this one. Seems pretty simple, right? When you learn a new fact, something has to physically change inside your brain. But what is it, and where does it happen?
That's Richard Feynman, one of the greatest minds of the 20th century, just flat out admitting, we have no idea. And for him, that wasn't a failure. Science wasn't a big book of answers. It was this thrilling, ongoing adventure into mystery. The unsolved problems? Oh, that was the most exciting part of all.
Which brings us all the way back to the beginning. Does all this knowledge about atoms and energy and the cosmos, does it make the world less magical? For Feynman, the answer was a huge, resounding no.
He'd say, sure, I can see the beautiful twinkling lights in the night sky, just like the poet does. But then he could see so much more. He could see giant balls of nuclear fire. He could see light that has traveled for millions of years just to reach his eye. He could see the very stardust that he himself was made of. The science didn't subtract from the beauty. It added these incredible new layers of depth and meaning.
You know, think about a flower. To our eyes, it's yellow, maybe white. But to a bee, it's a whole different world. Bees can see an ultraviolet light, which reveals these amazing patterns on the petals, like landing strips, that are completely invisible to us. Knowing that doesn't make the flower less beautiful. It adds a secret layer, a hidden reality that science actually lets us peek into. And at the end of the day, that's the Feynman Method. It's all about curiosity, about being honest with yourself, and about believing that the more you learn, the more wonderful and amazing the world truly becomes. So the question he really leaves us with is this: how much more is out there for us to see, if we just learn how to look?